Hey everybody, I'm Sherry Seligson. I am happy to be here again. Happy Thursday. Today's Thursday and we are outside today. I'm gonna wait just a couple minutes as some people jump on. Again, this is Thursday and we're gonna do some more fun science. As I see you guys come on, let us know where you're from. Love to know who's joining us today. I've got some fun things to do. I'm so glad everybody's here. Hi everybody. As you join in, I'd love to hear where you are, what you're doing, what you've liked about some of the things you've done, if you've tried some of those experiments. Today we're going to play with dry ice. And I say play, but this is something you got to be careful with. And I'll talk a little bit about what dry ice is and things that we can do with dry ice. I had to hit the grocery store today, and so since I went out, I was able to get some fun stuff. Our grocery store, one of our grocery stores, very interestingly sells dry ice. I don't know what people use it for food sources or anything, but I use it for fun and science stuff. And so I've got dry ice here, and let me just show you. I'm wearing a glove, and I've got some eye protection because this stuff is colder than ice. Okay, this is dry ice here. What dry ice is solid carbon dioxide gas. Okay, carbon dioxide is a gas that's in the air that we breathe. And if you get it cold enough, it becomes solid. And what's interesting about carbon dioxide, when it's in its solid form, it actually goes through the process of melting and then evaporating all at once. If you think about a cube of ice, I'm gonna put this down because it's really cold. Okay, if you think about a cube of ice is frozen water, right? It's solid water. And then you add more heat to it and it becomes liquid. It melts and becomes liquid water. And then if you add enough heat to that, it actually will evaporate and become gaseous water. So those are the three phases of matter: solid, liquid, and gas. Well, what happens is with carbon dioxide, when it becomes solid, it actually skips the liquid layer or the liquid state, and it jumps to gaseous carbon dioxide. This is called sublimation. It's skipping a phase and going from solid to gaseous carbon dioxide. And you can see it's the gas that's escaping right out of here as it's melting. That's a really windy day, which is not fun and not good for what we want to do. But I'm hoping it's going to work out, because one of the cool things about carbon dioxide is we know it's carbon dioxide because of the way it behaves and the things that it does. When we talk about any kind of molecules, they are a specific molecule that behave in specific ways, no matter what. And there's lots of other ways we can make carbon dioxide. For example, we've done this before together, but you can take baking soda. I'm going to take a little bit of baking soda and vinegar. And this creates a chemical reaction when you mix them together where you create carbon dioxide gas, among other things. So I'm doing this on a tray. And one of the interesting properties of carbon dioxide gas is that it is heavier or more mass than air, the air around it. And so when we light a match, and I'm hoping this is going to work because, again, there's lots of wind blowing things around. Let me add a little bit more. I keep adding this to create more and more carbon dioxide gas, which pushes the air out. What's left inside is carbon dioxide gas only because it stays down there. And it's not going to work because it's windy. We'll try it again. Let's see if I can get it to work. All right, let's try. Before I break my match. Let's try it again. No. This may not work outside. Yeah, it's not really going to work that well. Let me see if I can try one more time and hide block the wind. Of course, then you can't see it, can you? Can you see that? You can see that? Okay, I'm going to try to stick it down in here. And it, of course, has now been blown away. Okay, well, it's died down a bit. The wind has died a bit. Let's try it again. Add a little more carbon dioxide, which overflowed, which is why you do this on a tray or outside. Not a problem if it lands in this is my science tray. And then it goes out. Did you see that? What happens is, fire has to have oxygen as fuel. It's one of the components of fuel. And so when there's not oxygen, then it cannot burn. And so that's what's happening here with this carbon dioxide. There's another type of carbon dioxide we're familiar with, and that's when you take a soda or cola or pop or whatever you guys call it in your part of the world. What do you guys call that? Everybody has their own thing. The bubbles that are created here are carbon dioxide gas. So you can do both of these at home and just keep adding a little bit at a time, and that's creating carbon dioxide gas as the gas has been dissolved in the liquid. And then try it again with a match. should go out. There it goes. All right. That's because carbon dioxide gas goes out too, because it's heavier, it has more mass than oxygen. We're going to do this again tomorrow because I want to show you something else that actually, so you can tangibly see that carbon dioxide has more mass and is heavier than oxygen. But what I really want to do is work with this fun dry ice that we have. So I have my hammer because I broke it up with a hammer. I'm going to bring my bowl over here, and then I'm going to add water to help the sublimation process. Okay, look at that. Isn't that fun? You can hear it bubbling. I can hear it bubbling. I don't know if you guys can hear it bubbling or not. Okay, what's really fun about this is you can do some really neat things with it. One of the things I want to do is I want to take some of them and put them in this bowl, and I'm using tongs. Again, do not, if you have dry ice at home, do not touch it with your hands, because you will actually get kind of the opposite of a burn, but just as bad, just as painful, okay? All right, so now I'm going to move it over here, move this back, and I want to do it in a clear bowl because I want you to be able to see what we're going to do. We're going to actually try to capture the carbon dioxide gas. And you can see, as long as it's still, it kind of sits like a soup inside the bowl. All right, so I've got a container of water, and I'm going to add some dish soap to it. Just want it nice and soapy. Stir it around a little bit. And then I'm going to take a strip of fabric, just a strip of fabric, and I'm going to soak the fabric in the bubble soap. And we're going to try to capture or contain this carbon dioxide gas. Again, it's a really windy day, so we may have to do this again tomorrow, but let's just try it. So I've got my bubble soap here, and then I'm going to try to rub it across the rim and create let's try this way. I'm trying to create a film of soap across the top. Takes a couple of tries. Let me add some, and the wind is not my friend today. Ugh. I thought it would be good to do this outside. Now, we may not be able to do this tomorrow because I don't know what will happen to my dry ice by tomorrow. It will, oh, there we go, there we go. Look at that, guys. Can you see it? Can you see the bubble that's formed? It's a film of soap. Oh, and then it pops. Now, if it's not windy outside, and you try this, oh, there we go, I did it again. Then you can get the bubble to get really, really large before it actually pops, and you'll get the flowing of the carbon dioxide gas out. Again, this is carbon dioxide. Now, carbon dioxide, yesterday we celebrated Earth Day. Earth Day is just a way of thinking about the environment, how we affect the environment, and carbon dioxide is considered a greenhouse gas, and indeed it is. Oh, there we go. It's a greenhouse gas, and it has, like I said, it has very specific properties. Look at this beautiful bubble. Ah, there it goes again. I'm going to keep doing that. But carbon dioxide can absorb heat, which is a good thing because the environment, the atmosphere surrounding our Earth, I'll just keep doing this as long as it's working because it's so much fun. The atmosphere around our Earth behaves like a blanket, and that blanket keeps our Earth warm. If we did not have our atmosphere and it didn't trap solar energy inside, the Earth would be very, very cold and we could not survive. And there's actually a lot of reasons our atmosphere is helpful. Look at this beautiful bubble. Once that wind dies down, look how big it's getting. You guys try it if you ever have that opportunity to get dry ice. Carefully utilize it, play with it, because it's so much fun to play with. And it's carbon dioxide gas. So it's the same material that's in a soda. It's the same material the gas that's created when you use baking soda and vinegar together. And when you add water, you're helping it to melt faster or sublimate. Now I'm going to do one more thing. I'm going to add a whole bunch of bubble soap to this, or dish soap. And what this will hopefully do, stir it around a bit. And what's going to happen is as that gas sublimates, the bubbles of the bubble soap will trap it. And so you can pop a bubble, boop, and you release the gas. Can you see that? Now we have to do this, I like to do this outside because carbon dioxide gas by itself is not good for us to breathe. There's no oxygen in carbon dioxide gas, and we need oxygen. And so you have to be careful when you're doing this, but it's just really lots of fun to play with because you can see, look at that, how fun that is. You can see the properties of this gas and how it behaves, and no matter how we get carbon dioxide gas, whether it's from sublimation of the dry ice that goes straight from a solid to a gas direct, it's skipping the liquid phase, or whether we get it from soda, or whether we get it from baking soda and vinegar or other means, it's still carbon dioxide gas, which is 1 atom of carbon, 2 atoms of oxygen, carbon dioxide, that's why it's called that. And it's gonna have the same properties no matter where we get it from or how it's formed. And one of the properties of carbon dioxide gas is that it holds in heat really well, it absorbs heat very well. And it's a part of the greenhouse gases of our Earth's atmosphere, which help to be that beautiful blanket to keep us warm as a planet so we don't get freezing cold and all die, which is what would happen if we didn't have enough. Now, we can talk about too much, and that's another conversation. But I wanted you to understand that one of the cool things about chemistry is it's always the same, that it's always going to behave the way that it was designed to behave, no matter where it comes from. And we can see its properties as we do this with the dish soap and water. This is just dry ice, dish soap, and water. And again, you can do the same thing by just running that soapy strip of fabric across the top of it. And just have fun doing this. So I hope you guys enjoyed this. This is a really fun lab, but again, it's a very, one you have to be cautious with. Make sure if you do anything with dry ice, you've got a glove, you've got eye protection, you have some tongs, you have some protected area of your surface so that you're safe when you do this. And I hope you enjoyed this. I love talking about this kind of stuff, and I will join you guys again, Lord willing, tomorrow. Have a wonderful Thursday.